Multiplicative inverse notes. Here are some examples of identity matrix. A 1 by 1 is just a 1. 2 by 2 would have a 1, 0, 0, 1. A 3 by 3 would have a main diagonal of 3 ones, and all the other entries as 0. So to determine if two matrices are inverses, we're going to multiply A times B and B times A, done in multiplying matrices. If the result is the identity matrix shown above, then the matrices are inverses. So let's try it out with this one. I'm going to do A times B. And row 1, column 1. Be -2 plus 3 is 1. Then row 1, column 2. So -4 plus 4, 0. So far, so good. 3 over 2 times 1, 3 over 2. -1/2 times 3, -3 over 2. So if we subtract those, we get 0. And 3 over 2 times 2 is 3, because you cancel out the 3's. Then -1/2 of 4 is 2. So if we subtract those, we get 1. Okay, then we're going to do B times A on this one. So we're going to reverse it, and we're going to put 1, 2, 3, 4 first, followed by the -2, 1, 3 over 2, -1/2. And then we're going to see if we get the same identity matrix. So then we're going to do row 1, column 1. So -2 plus 3 is 1. Row 1, 1 times 1 minus 2 over 2 is 1. So that's going to be 0. Then row 2, column 1, -6 plus 6, 0. Then 3 minus 2 is 1. Both of them give us the identity matrix as shown above right here. So first we've seen that they're inverses of each other, and now we're going to find the inverse of a matrix using this formula right here. So we're going to do A, B, C, and D. So we're going to do 1 over A times B, that's 24, minus B times C, that's 2. That's 1 over 22. Then the matrix that we're multiplying it by is not the original matrix. It's where we switch the A and the D, like shown here. So we're going to put 4 here and 6 here instead. I'm going to switch the sign of B and C. So B and C are going to switch signs. So if they start off positive, we're going to make them negative. From there, it's like a scalar multiplication where you're just going to multiply the 1 over 2 through to all elements, not just the first one, with the result of 2 over 11, -1 over 22, -1 over 11, and 3 over 11. Okay, making sure that you notice we reduce the fractions as we multiply through, like 4 over 22 divided by 2 became 2 over 11. All right, we're going to do the next one the same way. Do 1 over -8 minus -20 is 1 over 12. And then we're going to switcheroo these two. So 8 and -1 are going to switch places. And then 5 and -4 are going to switch signs. So -5, +4, and then distribute. 2 over 3, -5 over 12. 1 over 3, -1 over 12. As you can see, 8 over 12 became the 2 over 3 by dividing by 4. All right, so let's say we had a system of equations such as this one. We're going to take the coefficients and make it into a matrix. Then we're going to have the variables x and y, and the results written as its own matrix, 1 and 3. Now, to get the result for x, which is a variable matrix, we're going to have to do the inverse of the coefficient matrix, followed by multiplying by matrix B, which is the constant matrix. So if we do this, we're going to get 5 minus 6, so 1 over 5 minus 6 is 1 over -1, so it's going to be -1. And then we're going to switch up the 5 and the 1, switch up the 3 and the 2 in reference to the signs, and then distribute, which gives us this inverse matrix right here. Then you're going to multiply that by 1 and 3. So if we do that, we're going to get -5 plus 9 is 4. Then 2 minus 3 is -1. So our answer as an ordered pair would be 4, -1. All right, so with this one, we're going to set it up as we did in the previous example. 4, 7, 2, 3, variable matrix x, y, constant matrix -16, -4. So to solve this system, we're going to do the inverse of the coefficient matrix times the constant matrix will give us the result for x and y. And then you would do an ordered pair x, y. So let's find it. So we have 1 over 12 minus 14 is -1/2. And then we're going to switcheroo these. 3, 4. Then change the signs of 7 and 2. So -7, -2. Is going to be -3 over 2. 7 over 2. 1 and -2. Then we're going to multiply that by the constant matrix, like so. Then we're going to multiply row 1, column 1, so it's going to be a negative or 24 plus -14 is 10. And then we're going to use row 2, column 1, so -16 and 8 is -8. So your x and your y is 10 and -8. You can always check it in the system to make sure it works. We have this one. We're going to have 1, negative 1, 9, negative 10. Find the inverse, and then we're going to multiply it by the constant matrix. 4, 45. And then that's going to give us the values of x and y. So then we have 1 over a times d, negative 10, minus b times c is negative 9. So it's going to be 1 over negative 1. So that's negative 1 distributed in to switching of 1 and negative 10. So that's negative 10 and 1. And changing the signs of those is 1 and negative 9. It's going to be 10, negative 1, 9, negative 1. All right, so let's make sure we have this here. We have 1 over negative 1. It's negative 1. We switch those around, distribute in the negative 1. And then we're going to multiply it by the constant matrix. So row 1, column 1, be 40 minus 45. Negative 5. And then row 2, column 1, 36 minus 45 is negative 9. So if we fill it in, we get negative 5 minus negative 9, which does give us 4. Great. So our answer for x and y would be negative 5, comma, negative 9. Complete.